declare the importance of the global gathering. So let us take a moment to reflect on the key highlights of yesterday's keynote speakers. The first keynote speaker was Dr. Girish Kumar Gupta, Professor Neonatology and Pediatric Graphicera, Institute of Medical Science, highlighted AI transformative impact on medicines, focusing on real-time diagnostic, personalized treatment, and advancement like fetal programming. The second keynote was Dr. Sandeep Kumar Garg, Professor IIT Roorkee, shared actionable strategy on integrating sustainability into computational practice in his talk. And the third keynote was Dr. Bogdan Gita, Associate Professor, University of Plymouth, UK, presented innovative AI-driven techniques for enhancing cybersecurity systems. Additionally, we witnessed the presentation of around 60 research papers, each contributing invaluable knowledge and paving the way of deeper discussions. Today we have an exciting lineup of keynote addresses and technical sessions that highlights the transformative potential of interdisciplinary collaborations. I encourage you to actively engage, ask questions, and foster meaningful connections. Today, our first keynote speaker for the day is Dr. Shashidhar G. Koolagudi, Professor, Department of Computer Science, IIT Karnataka. Now may I request conference convener to kindly felicitate Dr. Koolagudi sir, and I request Koolagudi sir to please come on the podium, and I request all the participants please honor with a big, huge round of applause. I request both the conveners to felicitate Dr. Koolagudi sir. Now may I request Dr. Manoj Divakar, Professor, Computer Science Department, kindly honor Dr. Koolagudi with a shawl as a token of our gratitude and respect. Thank you very much, sir. Please have a seat, sir. Yes. Dr. Shashidhar G. Koolagudi is a professor at Department of Computer Science and Engineering, National Institute of Technology, Karnataka. His area of interest include machine learning, pattern recognition, feature extraction, neural networks, artificial intelligence, signal processing, image processing, and computer vision. He is joining us to share his insights on sustainable technologies for the speech recognition. So please welcome once again on the podium with a huge round of applause. Over to you, sir.
जस्ट आप चेक कॉलम कॉलम कर दीजिए.
हेलो 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 हेलो
ठीक है
हेलो
लगता है. हेलो 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 हेलो.
ये तो मैंने किया.
हेलो
करना सर, अब करना चेक.
हेलो.
हाँ करो, अब करो.
नहीं आ रहा है ना. हेलो हेलो. उसको यूज़ करूँगा ना.
आपको यहीं से करना तो ये है, वो भी है. ये तो आपको अगर वॉकिंग करके बताना.
हाँ मगर कनेक्ट नहीं हो रहा.
यही है.
और नीचे यहाँ.
कोई नहीं, इससे भी चेंज कर सकते हैं.
हेलो हेलो
ज़रूरी नहीं है, इससे भी कर सकते हैं. हेलो 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 हेलो. ठीक है ठीक है.
हेलो 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 हेलो. हाँ राइट राइट. ठीक है ठीक है. हेलो हेलो. इट्स फाइन. respected faculty members, delegates from all different places, and dear students. So today my aim is just to introduce some areas of speech processing and how sustainable research has to be done, means what we used to do earlier, so how technology changed and how did we change and what changes we need to do in future so that speech technology research can sustain. Keeping the title of the conference, Sustainability in Technologies, I chose this topic. So now what we are seeing every day, everywhere is artificial intelligence, machine learning. So whether machine learning has got role in speech processing or not, that also I want to discuss. So before that, brief introduction about machine learning also we will see, because we have heard what machine learning is, or we have heard many times machine learning and all these kind of things. But what exactly is, how it started and what is its status today, these kind of things we will see. So first two are just introductory slides. This is about my place where I am working. This is 𝐂𝐨𝐧𝐿. Department of Computer Science was started in 1986. College was started in 1960. Earlier it was called as Regional Engineering College. Now it is called as National Institute of Technology. So our NIRF ranking is 17. So we have all these expertises: networks, medical imaging, speech processing, underwater communication. Any area you take, we have there the experts. Labs are open 24/7. So nice facilities you have. If you come towards south once, you can come and visit there. You can take my phone number from the organizers and you can call me and come there. It's a nice place. So what is that backside white one you are seeing? Can you guess? It was written there. That's a sea, Arabian Sea. Just this is a view from my cabin. So this is part of NITK itself. After that it is sea view. So at least to see this you can come there, all of you. So let us see the status of AI today. Majority of the students, majority of us, now if we want to start our day, we will ask, because we do not know what is to be done, what is important today, and we have reached a situation, we are asking ChatGPT or some AI tool, so what are the tasks for me today? So this much dependency we have on AI today. And earlier, how was it started? Just I have put some cartoons from the internet which will match this growth of AI. So in the beginning, once machine learning was there, all industries were very much eager to know that and implement that in their setup. So boss was telling, our vice president heard some word about machine learning and we want to include that, will you do that? So all workers were just ignorant about that and they were telling that I am not expert in that, I don't want to do it. This is a situation just around 15 years before. So slowly the situation got changed, people started talking about that, but still they did not have much knowledge about it. So once machine learning is used, people thought of keeping some machines on the benches and teaching them or learning them. Yes, it's a cartoon like. So many machines are there and teacher is teaching those machines. Probably if teacher is also replaced by a machine, that would be better representation. So this was understanding, means everyone was not knowing about that. This technology, machine learning, has taken a role mostly after 1995. Before that, we also had studied some subjects. If any seniors are there, you might be knowing, we used to study one subject called as Artificial Intelligence by 𝐈𝐧𝐿, that book. So it was totally different. The way machine learning has developed today, it's not at all related to that book. That was totally different. We will see. And why this machine learning or has taken so much importance and how people said about it. This person you might be knowing, he is a Herbert Simon. Have you heard about Turing Award? What is that? it is called as Nobel Prize of Computer Science because in computer science we do not have Nobel Prize. In computer science we have only prizes in 6 areas where computer science is not there. So in today without computers nothing is there. So people thought of we will establish one good award in computer science. So they awarded Turing Award. Why is it called as Turing Award? Turing is the name of a person who had given concept of today's computing machines. Today's computing machines, once we say, they have got input device, they have got output device, they have got storage and processing unit. So all this concept for the first time was given in 1930-35 by this person Alan Turing. So on his name this prize is installed. That award was given to this person Herbert Simon in 1975, and he also was given in 1978 Nobel Prize for Economics. So that talks about credentials of this person. He has defined machine learning earlier like this: learning is any process by which a system improves performance from experience. As human beings, it's a very general definition. So if we are doing something today, and if my performance is improved tomorrow because of the experience what I have today, that's called as I am learning something. So that way, if machines also do, means if you are writing one C program today and if you miss semicolon and you say that semicolon is missing semicolon is an error, tomorrow that kind of error his system should not do. But do we have such systems now? If you miss a semicolon, whether system will automatically put semicolon? In our education environment, what programming we are doing, we have not seen such systems, but such systems have already come. You might be knowing that systems can even generate programs. For many applications now, programs are being generated by systems. Means machines have started learning the things as human beings learn from our experience. So what is another term for experience? Another term for experience is doing many mistakes. If I say I have 20 years of experience, in 20 years I kept on doing some mistakes, but it can be turned into experience once I do not do same mistake again. If I keep on doing the same mistakes again and again, it's not called as experience, isn't it? It's a negative way of calling it as. So now the major difference between common programming by computer and machine learning. Just you see, in common traditional programming, which we call as procedural programming, we have data and we have program. Program is a procedure, how to solve that problem. And this program does certain transformation on a data and we get output. Say for example, unsorted list of 10 numbers, I write a program for sorting, then the output will be sorted list. Unsorted list is transformed into sorted list. That's why we are doing. But what machine learning will do, it takes data and it takes output and generates a procedure. It will not generate exactly procedure, but it will learn how to do it. So we have many unsorted lists and one sorted list. So give this unsorted list also as an input and sorted list also is input. Whenever this kind of input is given, output should be like this. So for that a system develops a program or a procedure. That's a machine learning. Means we tell what is input, what is output, then it generates a system. So that's all is happening in machine learning. Slowly the trend changed. People started working on machine learning. Then at the top level, people started believing what machine learning can do for their company. So boss is telling his decisions aren't any better than yours, but they are very fast. Computers are also doing what you are doing. He is telling to a human colleague, computers are also doing what you are doing, but they are much faster than you. ChatGPT, if you want to find answer for any difficult question in ChatGPT, how much time do you need? 2 seconds, 1 second, isn't it? If you want to go to library, read all those things, consolidate them, then summarize them, then write, probably one whole day also is not sufficient. Even if you do that, some information will be missing. So people started believing in the capabilities of computers. So everywhere we have applications of machine learning. So any area you take, these are very broad areas: neurosciences, physics, statistics, then computer science, artificial intelligence. Everywhere we have applications of machine learning. So this is called as world cloud. Here the font size and the darkness of the font tells importance of that. So if you consider ML applications, machine learning applications, computer vision, diagnosis, hospitals, bioinformatics, image processing, in all these areas we are highly dependent on machine learning. There are some other small areas also like e-commerce and fraud detection and these kind of things where use of machine learning has been started, but still it has to grow. Mainly there are all these steps are common for all machine learning applications. So first we gather data, collect data. Probably next one more slide will explain this better. So we collect data, then data are collected from the sensors. So all this sensor collected data, slide is now, the collected data is pre-processed. Pre-processed means it is made ready for machine learning algorithms. So after that we have some algorithms which we call as machine learning algorithms. They learn this data and they will have a capability to decide something. Then we give testing and we get the final result. This is a common process. It is same as how human beings learn the things. So if there is a small child of around 1 or 2 years, if you give some 10 different items to that child and ask that child to classify, 1-year child will not have knowledge of color. Probably it will classify them on the basis of weight, it will classify them on the basis of shape, something like that. So it learns and then it does. The same way machines learn and then they do the classification or whatever we want. So don't worry much about them. So some of the important things that we need to understand. Machine learning is more feasible while we have lot of data. If lot of data is not there, then probably machine learning will not work properly. So prerequisite for machine learning is data warehousing, data mining, those subjects you might have studied. I hope you are studying. Have you studied data warehousing, data mining? Not studied? So one small example I want to give you, that red one, data mining is there, no? So there is one thing called as, or one question I will put, you can answer that question so that we will see how it goes. So have you, please be seated, sir. So have you, no problem. Have you seen any time if you go to supermarkets, on what basis items are kept on the shelves? If you go to supermarkets, many things are kept on the shelves, isn't it? On what basis are they kept? Simply, are they kept random basis? Can anybody tell? On what basis are they kept? Do you know that there is some base in keeping all of them? Normally once we go to shopping malls, plan was to purchase some 10 items. Before, for family holders they know that, before we go to those shops, we will have a plan of purchasing 10 items. By the time we come out of that shopping mall, we will have 100 items in our basket. We were planning to spend around 1,000 rupees, but by the time we come out, it will be 2,000, 2,500 rupees like that. So what makes us to do all those things? We were, please. More discounts are there, so seeing those discounts, one, if you purchase one, another thing is free. So that's one thing. Next, good. Sir? Associate mining, very good. What is that associate mining? You said right. What is associate mining? Yes, they identify the relations between different items and all the related items they keep side by side. So all vegetables at one side, all fruits at one side. If you want to purchase only apple, if you see some other good fruits, you also purchase them. Fine. If you put a computer, then also there will be a printer side by. Fine. So this way, it's called as association rule mining, as sir said. So that's a very important concept in data mining. So normally what they do is they study last 1 year, every day 10,000 customers are visiting, they study purchase pattern of all customers. How, on what basis customers purchase items. If there are many people who have purchased 2 or 3 items together, then they understand that there is a trend in people. Normally one who purchases item X, he also will purchase item Y. Then they keep item X and item Y side by side on the shelf. So whenever a person goes for purchasing X, he also will be lured by side by item is kept there, item Y, he also will end up in purchasing that. So it increases business of those people and it makes our pocket empty. Fine. This is one technique. So if you give the same approach, same task to a human being to do, take all receipts in the last 1 year, every day 10,000 receipts, and analyze who has purchased, how many people have purchased some items together. That's called as association rule mining. It's very difficult for human beings, isn't it? Each person has purchased 100, 200 items, search them, who has purchased which items together, and list them and say that 20% of the people have purchased these items together. It's very difficult. So there are some items, some tasks which human beings can do, but it's very tedious. Computers can very easily do that. It's a job of some 2-3 seconds for that. Fine. So association rule mining was one. Is working? Okay. Association rule mining is one such thing where it's a beginning of, we can say that it's a beginning of artificial intelligence, or it's a beginning of machine learning, where machine started learning the trends of people, the trends that's going on in the people. Recently once similar study is done in Walmart, America. They found one association. That association was between beer and baby napkins. Between beer and baby napkins. Can you think what is the interpretation of this? Means many people, around 20% of the people who have purchased baby napkins have also purchased beer. It's not in India, in America. What might be your interpretation of this? This data mining can also be used for social sentiment analysis and social behavior of people. So any guess for this? Means ladies are stressed out because of the children, so they want to drink beer, or what? Other guess? Any other reasons? You can, it's a wild guess you can do, isn't it? Later they want to put diaper to their children and they want to sleep properly, so they drink and sleep. Fine, good. Any other guesses? So after thorough analysis, they had seen. Now we are observing that in India also, if you go to any classroom, especially in computer science, electronics, these kind of branches, what's the gender ratio of boys and girls? 30 boys. 30 girls, 70 boys. Still that is fine, but in some colleges I have seen 30 boys and 70 girls. 30 boys and 70, that's true. In many private colleges that is true. So because this is what happens, finally female partners of the family will become bread earners of the family, and male partners of the family will be taking care of the family. So once they are taking care of the family, children are to be taken care by male partners. Female partners will go for job. Then what will they do after making that boy or girl, small girl, eat something and sleep? What these male partners will do? They want to booze. So that's what, this was a relation. This was a social impact, or this was a social thing which was identified by data mining. So just for these kind of applications also we can use. Let's not spend much time on this. So why now? Machine learning has taken its role a lot now today, especially in the last 5-6 years. The reason is these 4 important reasons. There is a flood of data. Earlier there was no data. If 20 years before, if you want to do some research where you want to identify which flower is this, then the person who wanted to do that research has to go to different gardens, take photographs on that roll based camera, take a photograph of all pictures, scan them, keep them in some directory and then separate them and do all that thing. It was not easy. Data collection itself would have taken some 6 months, 8 months, 1 year for him. But now that's not the case. If there's one nice flower in my house, then what I will do, I'll take a photograph of that, good morning, and send it to 1,000 people. Morning, isn't it? We do that. So now there is no dearth of data. This is not only in case of social forums, but it is everywhere. Whatever data we want, we have sufficient amount of data, because everything is digitized, everything is computerized. All bills, you have any stock market fluctuations, you have that data. Any hospitals you go, you have that data. Kaggle and Keras you might be knowing. So on that platform, if you see anything that you want to do, you have sufficient number of samples, data samples. So this is the right time for us to automate. That's one reason. Next thing is computational power. Computational power. If you think some 20, 30 years before, which was microprocessor used for the first desktop? Desktops we are using now, isn't it? Laptops we are using, laptop, mobiles fine, but little earlier, some 5, 6 years before, we were using desktop. So desktops were built around microprocessors, isn't it? Which was the microprocessor used for building first desktop? 8085U. 8085U was used, but it was not commercially used in the market. 8086, next version. 8086 was a microprocessor which was used. So what was the RAM size of 8086? What is the RAM size now? RAM you are using, no? Laptop, desktop, what's the RAM size? 16 GB, 32 GB, 8 GB. So RAM size of 8086 machine? Lesser than that. Lesser than that. 1 MB. So we had 20 address lines. 20 address lines, 2 to the power 20 is 1 MB. So 1 MB was a RAM size. Think of whatever machines we are using, 16 GB machine, it is slow for us. Whenever we are playing game, it will not respond through for our working. So we feel that it is slow, but at that time it was a 1 MB machine. Think of what those people would have been doing. So now there is sufficient support from the hardware. Second point, increasing computational power. So whenever we want our computer to process so many images and all, it needs a lot of computational power. We have GPUs, you might have heard, graphical processing units, CPUs, then GPUs. So then growing progress in available algorithms. Many algorithms are there in machine learning now. Earlier there were only statistical AI tools like Gaussian mixture model, averaging, these kind of things. But now we have neural networks, then convolution neural networks, then recurrent neural networks, then deep learning. So lot of algorithms which are faster and more perfect in learning patterns, those are there. So technology support. Then there is sufficient funding. Many industries are supporting through fund if you want to do certain research on AI, ML. So this is the right time for us. So all these things we have. So machine learning is flourishing, and also we have in many colleges machine learning, computer science in the bracket AI, ML branch. So all those things you need to know. So these things I will miss. But in general now any field you take, without machine learning there is no any expert decision. You go to doctors, doctors might have done multi-super speciality, but without MRI he will not be able to take decision. Without blood test he will not be able to take decision. Diagnosis is not there. All of you might be knowing earlier means around 300, 400, 500 in Mughal period, normally ladies were not coming out of home. So if they are sick, then there were some doctors called as Hakims. Those Hakims were called. So then there used to be one thread. One end of the thread was held by that lady, another end of the thread is held by this Hakim. He used to sense pulse of that lady through that thread just by holding it like this. And he used to tell what has happened to her, and he used to give medicine. Fine. That's a knowledge which was there. Just some 5, 6 years, 10 years before, if you see, whenever you go to hospital, doctors used to hold your and test your pulse. Whether any doctor is testing that pulse now? At least in the last 4 or 5 years, I have not seen any doctor holding like this and testing the pulse. What doctors sense there? Have you observed how many fingers they used to keep here? 2? Is it 2? But I have seen 3. 3. It is 3. So why 3? Why 3? In Ayurveda, 3 kind of major conditions of the body, not diseases, conditions of body in Ayurveda: Vata, Pitta, Kapha. These 3 different fingers keeping on the same blood vessel sense different things, and they used to decide what has happened to you. That knowledge has gone. Stethoscope has come, MRI has come, all scans have come, all that knowledge, even from the doctors, it is not there. Even from computer science engineers, some 10-15 years before, computer science engineer is expected to know every hardware, how computer works. Where is your file stored? How to store it? They used to remember big commands: DOS, disk operating system, Unix, earlier Unix, now you are in the GUI of Unix. Means slowly that knowledge is being taken away from human beings, and we are giving everything to machine learning. Fine. So do you know some organ is there in our body called as appendix? All of you know, isn't it? What is the role of that appendix? Nothing. It's a vestigial organ. It's called as vestigial organ, useless organ. Why is it useless organ? It's a part of digestive system, but it's not doing any task. Why is it not doing any task? But in cows and all, it is fully developed. In herbivorous animals, it is fully developed. What is the role of appendix in those animals? It digests raw food or cellulose. It digests cellulose which is in the plant cell body. Plant cell body, that cellulose is. Now we are not eating any raw plants. Doctors say eat greeny vegetables, but we don't eat greeny vegetables. We bring them, we cut them, we boil them, we fry them. So many things we do on them, then we eat. So cellulose is not there. And this we are doing thousands of years. So that appendix thought that I don't have any job. Then slowly it became jobless. And Lamarckism, you know, isn't it? Darwinism, Lamarckism, biology, if you had studied in your +2. What is Lamarckism? Used organs grow stronger. I am using my right hand more, so my right hand is more efficient and stronger than my left hand, isn't it? So appendix, there is no work since 1000 years. So it lost working, it has become vestigial organ. Vestigial organ means useless organ. But being useless organ, it will not keep quiet. Many times it troubles, isn't it? Appendix, and you get pet dard, then appendix has to be removed, all those things are there. So now all youngsters, we are giving all intelligent activities to computers. We are not doing. We are not giving any work to our brain. If you continue it for another 500 years, brain becomes vestigial organ. So it will be out from the body. Sometimes if it start creating some trouble, you may have to remove it, like appendix we remove. But it's an extreme case. Just now it looks like a joke, but already it is happening. Are there any carpenters, pottery making people, blacksmiths in villages now? If you see in Jaipur some palaces, we cannot imagine that such a woodwork was done. If you see some old temples in South Karnataka, especially Tamil Nadu, you cannot imagine Brihadeshwara temple, Tanjavur. You cannot imagine that that kind of carving can be done in stones. Now we cannot do that. For preparing one statue of Sri Rama for Ram Mandira, that person took 6 to 8 months. But such a beautiful temples, they were built in 5-6 years. So that knowledge has gone. It is going slowly, majority, many of the knowledges are going out of us. So means we are losing our brain capabilities. So just to keep it funny, I said like that. Now this also we need not worry. Now driverless cars are there. slowly now new cars have come where we need not apply gears. So, but the fun of, the happiness of driving lies in changing the gear and all those things. So that happens finally, drivers are also not required. Driving will go out of our mind. So some basic things I want to share here. Are these discussed earlier, yesterday by someone? No? Just see, this is for students. Teachers might be knowing all these things. You might have heard about classifiers, isn't it? All machine learning algorithms are basically classifiers. They classify the given items into different groups. If I want to classify boys and girls, then I want one classifier. Like that, this is a classifier which classifies red dots and blue dots in a plane. So what is a classifier? The classifier is basically this line. This line separates red dots and blue dots. So these kind of classifiers are called as linear classifiers. Linear classifiers because classifier is a line. If classifier is line, linear. If classifier is a line, then that is linear classifier. If it is a plane, there can be a linear classifier. Say I want to classify, I want to separate this room into two. So whether line will do that? Are you getting my question? What will separate then? Plane will separate. So I want to put one cardboard partition here, one plywood partition here. That partition separates this line, this classroom into, or this hall into two. So whenever dimensions grow, then dimensions of the classifiers also will grow. Here dimension of data is 2. So dimension of classifier is 1. Once I say dimension, I am talking about order of the equation. What is the line equation? Y is equal to mx plus c. What is the order of this equation? It's 1 because power of x and power of y are 1. Likewise, what is the order of the plane? That's 2-dimensional. X, Y, Z, all these things you need. So room, it's 3-dimensional. Likewise, once you want to separate items in higher dimensional space, then the classifier also will be higher dimensional classifier. So it's called as classification hyperplane. Classification hyperplane. To understand that concept, just understand this one. Here line separates them. So this is linear classifier. So there are many lines separating them. You see now at least 1, 2, 3, 4, 5, 6, 7, 8. 8 lines are there which are classifying blue dots and red dots. Which classifier should we use and on what basis? Which one is most efficient? That's a confusion, isn't it? There is a confusion. All of them are proper classifiers. All of them will classify blue dots and red dots. But the most efficient classifier is, I don't know whether that is there or not. Yes. This is this line. This line is efficiently classifies them because from the neighboring points, the distance of this line is same. From the red points also distance is same. From the blue points also distance is same. Means this classifies them better, I said, because if some other red points come here, they are classified as red points. If some other blue points come here, they are classified as blue points. Fine. The classification line which maintains equal distance from both the classes is a best classifier. This is called as curve fitting. This is called as curve fitting. So points are given. To represent those points, I have to draw a curve. I have to draw a line. So whether green curve or a red line, which one represents those points in a better way? Representing means one representing curve I have to draw. So whether red line represents those points better or a green curve represents those points better, right? Just see that. Patterns you see, pattern you see. So points are like this and they are coming like this. Whether curve represents them or line represents them. Green curve represents them better, isn't it? But I cannot say that red line will not represent. A red line also represents them, but it is not an efficient representation. Fine. So whenever points are given, to learn those points, we have to tell computer mathematically which which curve or which shape will represent the points in a better manner. So, what is the order of this equation, line equation? 1, as I said, y equal to mx plus c. What is the order of this equation, this curve? What is the equation of a circle or parabola? X square plus y square equal to r square is a curve. The order is 2. So, once the line becomes curve, the order changes. If it is very much defined curve like a parabola or circle, order is 2. If it is zigzag curve, order is 4, 5, 6. If your equation is with a more order, solving that, working with that is difficult task. It's mathematically more complex. So, normally to represent given points, in general, we use in a most simpler way line, but line is always not sufficient. So, we go for other representations also like circle or parabola. Fine. This one is to be known. See here, this is also a classifier, line classifier, but is it right classifier? You have one blue dot here and you have one red dot there. It has, its purpose is to classify blue and red dots, but it did not complete its purpose. That is called as error in classification. Some errors will always be there based on some examples. Always in a data sample there will be outlier. Outlier means which is not commonly for following a pattern. Say for example, there is a class. In that class, normally if it is homogeneous class, date of birth will be 1 or 2 years more or less. If it is 2000 is a date, then some people might be 1999 and some people might be 2001. But if one person is 2006, because of his caliber he has taken admission to this class, that's an outlier. So, outlier will not decide pattern of the whole class, but there will be outliers. Similarly, these dot, blue dot and red dot are outliers. Outliers, they will not represent whole class, but still they are the parts of the class. So, once classification line is done or generally the classification is represented, some errors will be there. That is an error. Fine. The next are same earlier points. These are same points. Points are same, but classifier is different. Whether this one is efficient classifier or earlier one is efficient classifier. This one is efficient classifier because it separates all blue dots in one side and red dots on the other side. Does the task perfectly. But what is the equation of that curve? Whenever one turn comes, 1 degree increases. Thumb rule, you can keep it like that. So, this is of order 1, order 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 10 or 11 order equation, which is very difficult to, even by computers it is very difficult to manage. So, this kind of representation we can do, but while computation it needs a lot of computational power. We should not fix the classifier this way. Classifier, let it have some error, but it should be more generalized one. So, that is what is written here. So, there are 2 errors, one blue and one red, but it is a simple model. 0 errors, complicated model. Have you heard about overfitting, underfitting? Yes or no? Yes, at least. This tells about that. So, when we were young, we were very small. We were very small. So, whenever new dresses are to be purchased, I don't know these children have experienced that or not. New dresses are to be purchased. How parents used to purchase them? ढीला वाला, बड़ा वाला, और 2-3 साल ज़्यादा पहन सके, isn't it? So that way parents used to prepare. Otherwise, they used to bring, if some 4 or 5 children are there at home, they used to bring one big kapde ka tage. Then everyone used to get stitching from that cloth itself. So now that is not the case to majority of you, because you use dresses for 1 year and you throw them, isn't it? During our time, it was a plan of 5 years, 6 years. Some clause during my marriage still are there. So this is example of underfit. थोड़ा बड़ा ले लो 2-3 साल और आएगा. And this is overfit, perfectly fitting. थोड़ा भी वजन बढ़ जाए, you cannot use it. This is overfit. Fine. Fitting बहुत अच्छा से किया है, but it is not generalized one. It's not generalized one. That is, you cannot wear, but it doesn't look good. This is right fit. But taking this decision in case of machines is very difficult. Whether I have to draw a line, circle, parabola. So this is fitting the, as I said, curve fit. See here. Same, whatever you have seen earlier, that blazer, this example. So you have some points to be represented there, the top one, some points to be represented. So these points are represented by means of circle, and these points are represented by means of this curve. Two things are here. So one more thing is this one, third one, this one. So if you see all of them here, points are not shown, the same points here. There is one point here which is outlier, that was left by these classifiers, but this classifier, that yellow line, that is considering that also. But what happens in case of this? What happens in case of this is, all this line, complete line, is passing through all the given points. If you see these given points, you can see the shape of the curve. You can see the shape of the curve here. Points are not shown, as I said. It is going through all of them. Right fit for these points will be this blue line. It generally represents them. That line, yellow line, would be too much generalized. Too much generalized. That's what it is underfit. It is overfit because it's passing through every point. Once it is passing, the line classifier that you are deciding is passing through every point, then if a new point comes, new point might not fall on the same line. It is like, if you want me to give another example, it is like after completion of the syllabus, teachers give most likely questions, isn't it? ये questions पढ़ लो, exam में आपको आसान हो जाएगा. Some people, some students, what they do, they study only those questions. ये भी बोलेंगे, out of these 8, only 5 questions you will get. Then they study only 5 questions out of that. And they come to the class. If those 5 questions, preparation is perfect. But what it is, his knowledge is limited to only those 5 questions. If a 6th different question comes, he will not be able to solve that. That is this example, overfit. Means study किया है, but क्या किया है? Only for those questions he has studied, perfectly studied. But थोड़ा सा एक अलग question आता है, he will not be able to solve it. So that is overfit. So ऐसे होता है यहाँ. So same thing will happen here, because it knows only the pattern of given points. One extra point comes, it will not be able to represent that point. Fine. It suits perfectly. The dress suits perfectly. थोड़ा सा इधर उधर हो जाए, it will not suit. So this is good fit. Here line is underfit because it's not representing in general. So if you come here also these points, actually these are green and these are red. The classifier should probably be like this. But we are trying to, not classifier, the curve which represents them. We are trying to represent it by a line which is not good, that is underfit. So this kind of a curve, fine, some errors are there, but still it is good because it is generalized one. But if you see here, all green points are that side, all red points are this side, it is perfectly doing all the things, but one new point comes, it will fail. This one will fail. But new points also it can accommodate, even though there are some errors. So whenever you decide a curve for given points, your fitting should be like this. Not like this, too much generalized, too much specific. Too much specific, overfit, too much generalized, underfit. These are the problems always we face once we are working with machine learning algorithms. This battery has to be changed, sir. Fine. So similarly, here You might have heard K nearest neighbor classifier, have you heard? So there are some classes, nearest classes, one new thing comes, where to put. We have some footballs, basketballs and tennis balls. So whenever a new element comes, this black ball, is it a football or a tennis ball, or one more is basketball, whatever, cricket ball, anything, any ball you can take. So where does it fit? Is this black one is a class of this, or is this one class of this, or that one class of that? So how do we see? We fit one circle centered at this black ball and put that circle. After putting that circle, if more green balls come inside that circle, then that black ball is also of green category. If more these balls come in that circle, then that will be of this category. That's called as K nearest neighbor algorithm. Simple, it is simple thing. But while implementing, we need to write some mathematical formula and all these kind of things. So that will happen. This one, please. See, this is a circle. More green balls are coming into that circle, so that black ball will be of the category green balls. So this is taught something as a big thing in class, isn't it? K nearest neighbor algorithm. Now I will not go into the details of speech, sustainability in speech research. So I don't know how much time I have. Next we will see how these, as I said earlier, we used to do only time domain research on speech signal. We have a speech signal. Speech signal will have some time domain properties. Let's not go into the details of that. We used to do that, and we used to do certain research, but it was very primitive and basic research. Later in electronics, some technology got developed, frequency domain analysis, Fourier transform and all these kind of things. Then we started doing frequency domain analysis of speech also. But now we have machine learning. Earlier we have Gaussian mixture models, statistical models we used to call them. Now we have deep learning models, neural network models. Accordingly, the area that we work, the applications that we do, the features that we extract, all of them are changed. So don't worry about the details of this speech processing. I will skip all of them. Okay. So this is a speech signal. This is a speech signal of the utterance speech lab. Speech lab. You can see different portions here. This is SIR part, speech SIR part, which looks like a noise. There is no proper format in the signal. This is E, SPE. This is A. A, you have some periodicity in the signal. E, you have some periodicity in the signal. I will expand that signal and you can see that. This periodicity says that that's a vowel portion. In the speech, if you see some, we call it as quasi-periodicity. It's not exactly periodic. Looks like a period, but not perfectly period. Not like your sine wave, cosine wave, like that. So if some periodicity is there, then it is vowel. If some noise kind of thing is there, it's just fricative. We call it as fricative. These kind of signals, these kind of sounds. Then sometimes you see here, there is no signal. These are called as stops. Normally consonants are stops. Ka, cha, ta, ta, pa, ga, ja, da, da, ba. All these are consonants. Devanagari scripts you know better than what I know, isn't it? So while pronouncing them, air that is coming out of your lungs will be stopped at some portion of your mouth. So they are called as stops. Can anybody pronounce here pa without closing your lips? Pa? You can try. Not possible. But there are some, I don't know what they are called as ventriloquists or those बात करने वाला एक गुड़िया रहता है, उसके साथ वो बात करते हैं ना, in some shows. What are they called as? Puppet show. But those puppet show people can pronounce po also without closing their lips because of practice, but it's not a proper pronunciation. But pa, pha, ba, bha, ma, these 5 consonants you cannot pronounce without closing your lips. Means air has to stop at your lips. Likewise, you have ka, cha, ta, ta, pa. Whenever you are pronouncing kavarga, ka, kha, ga, gha, nga, air has to stop at this portion, which we call as velar portion. Velar, then retroflex, then labial, all these portions, 5 classes, this Vargiya Vyanjana what we call, those 5 classes will have 5 stoppages of airs in different portions of your mouth. This pa, 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 ma is very clearly seen because we can see that, that's what I gave that example. So whenever air stops, there will not be signal. So this stop, during stop region there is no signal. So these are properties. Seeing these properties we can see which part of speech we are talking about. So here you see just in this junction of lab, l, a, I have expanded the speech. So this is a part which represents, I said period, this is one cycle, this is another cycle, third cycle. It's not exactly periodic, but it looks like a cycle. So quasi periodic signal, speech is a quasi periodic signal. Here it is quasi periodic, but it does not have fluctuating properties like vowel. So these are called as semi vowels. Which are semi vowels in Devanagari script? Ya, ra, la, va, sha, sha, sa, ha, all these are semi vowels. They behave like vowels, but they are not vowels. That's what they are kept as consonants. And those are vowels. A, e, all those are vowels. But see, one beautiful thing I want to tell you, this Devanagari all of you have studied, isn't it? Hindi alphabet set. So all 14 or some vowels, then you have 25 ka, cha, ta, ta, pa, 5 things, then ya, ra, la, va, Avargiya Vyanjana, Vargiya Vyanjana. When was this classification done? Do you know? Who did this classification? There was some person called as Panini. Panini's Vyakarana Shastra, you might have heard. If you have not heard, just you are hearing now, isn't it? Panini's Vyakarana Shastra, Panini did this when? Around 2500 years back. Panini's Ashtadhyayi, that's the name of the book. Around 2500 years back he has done. At that time no microphones, no computers to analyze the speech signal. So all these things, still they were knowing all sound patterns and sound signs. That's what you see, ka, kha, ga, gha, nga, if you see, the closure of the air will be ka, kha, ga, gha, no, ka, cha, ta, ta, pa. Once it is moving from your velar portion to lip portion. This kind of organization of phonemes was done 2500 years before, you just think. It was nowhere in the world at that time. Language, computer science students, have you heard about Noam Chomsky, the name of Noam Chomsky? Chomsky hierarchy of languages. He was there in 1950. TOC have you studied subject? Theory of computation, or what do you call it as? Theory of automata, same subject. Have you studied? In that Chomsky normal form? Yes, those grammars. So he was in 1950. In 1950, for the first time, he defined all languages. Before that, there was no proper definition. People were not able to give proper things. But in Indian culture, Indian scenario, format was given to grammar, even to sound units, 2500 years before. Just think our culture, what our culture, that will be different story, we will not go into that. It takes again a lot of time. So this also we need not worry. This talks about how speech is produced. Let's not worry. But some important applications which you can do as students, small projects, and faculty members also can give these things to your students as projects. So what is a signature? What is signature? Signature is authentication of myself. So if I put signature, means it's a representation of me, isn't it? Normally people started forging it. Normally students do that, isn't it? If teacher doesn't take assignments, then he will put signature and say that no, no sir, I had shown you, see here your signature. Then we ourselves will not be able to distinguish whether it is my signature or he has put it. Then we see, okay, okay, go. Fine. So it is vulnerable to forgery. Fine. So people thought of using something which cannot be forged. So how are we putting our attendance every day now? Through thumb, biometric thumb, isn't it? Thumb is one such trait, property of a person which cannot be forged easily, isn't it? My thumb you cannot forge, or your thumb your friend cannot forge. Fine. Those are called as biometric authentication. Biometric authentication. But during COVID also you did same biometric authentication. One person used to put thumb and again another person comes and puts a thumb there. At that time, breathing in front of other person was also not possible, isn't it? We used to put mask and all. So contact related biometric authentication was not possible in some cases, especially the best example all of us know, COVID. So contactless authentication we want to do. So what are the cases? Face recognition, iris, ear also, pattern of the ear, maybe that is the case. Then walking style of a person, that's called as gait, G-A-I-T, G-A-I-T. If you see three of your friends are coming for around half kilometer away, standing here, you can see them and you can say that the first one is Mahesh, the second one is Santosh, third one is someone, isn't it? On what basis? You know their walking style, that's gait. So all these analyses are non-contact biometric signatures. Similarly, speech can also be used as biometric signature. If speech can be used as a biometric signature, majority of digital frauds will be vanished. How do you authenticate your transaction in a bank now, today? Through OTP, isn't it? OTP. And somehow people will get to know your OTP and they do so many problems. Every day, 9,000 crores or more than that is a tune of digital frauds in India. I've heard about one IPS officer. He is a Karnataka based IPS officer. I don't know whether you have heard or not. Shankar Bidri. He was a person who was involved in Veerappan's case. Do you know Veerappan? Yes, Veerappan film also had come. So he was forest. He used to do so many stealings and these kind of things in forest, especially this sandalwood and ivory and these kind of things. So that IPS officer was in a mission to arrest him or something. Finally, Veerappan was killed. That is a different story. After retirement, that IPS officer who was serving for 20-25 years in that police department was frauded. He went different places and he himself could not trace where that money has gone, and money from his account was deducted. That is a tune of digital fraud. Instead of OTP, if you can authenticate yourself through your voice, you can say your name, just those kind of voice authentication has come in SBI. Recently SBI has got one channel where you can authenticate yourself through voice also. Majority of these problems will be solved. So voice can be used or speech can be used as a biometric signature, person identification, and don't have to worry much about the other things. Mobile applications, voice dialing, do you know? So if I say simply home, then it searches, that app searches through contacts, it searches home and it dials home. So even while you are driving also you can do that. Those kind of many applications can be developed in speech processing. Time is over, another 5 minutes. Okay. Good thing. So I will come to last slides. Don't worry about all these things because we will worry about them in another meeting one more time. So these are all the things which we had done during our work, different feature extraction techniques and all these kind of things. But what I will tell now is, so for what different applications this some recent machine learning tools can be used. This is one of my PhD students. He defended his thesis in 2020. His work was phonology analysis from children's speech. Phonology is how children learn speaking style. Some children learn some phonemes in the early stage, some children learn some other phonemes in the later stage. That's what if children are 6, 7 years of old also, they will not be able to distinguish properly between r and l. Totle bolte na sometimes. So this is a very systematic process of how different phonemes are learnt by children of small age. So this was a DST project and we studied that, and he got PhD also, the student. So in this one, I don't know whether we need to go to this much details or not. Let's not go into that. Just I will tell, these different clusters represent different vowels. These vowels, a, e, u, a, these are some vowels. This is for younger child, it seems. A is age between 3 to 3.5 years, B is 4 to 4.5 years, 5 is 5 to 5.5 years, the C. So if you see this image and this image, here there are a lot of overlaps because child has not properly understood the way of pronouncing a, e, u, all these things. But there better clustering we can see because child has studied or learnt it better. So for doing this, so these are also some features we had extracted like MFCC features, feature 1, feature 2. So clear clustering is there. All these things are fine, but for classifying them, he has used SVMs. SVM stand for support vector machines, RF, random forest. These were statistical classifiers. Statistical classifiers in the sense, data has got certain statistical property, use those statistical property to classify these things. Such statistical properties were earlier classifiers in the era of artificial intelligence and machine learning. First statistical classifiers, then you have machine learning, then you have deep learning, likewise. Today we are in the era of deep learning. All these CNNs, RNNs, CRNNs, these are all deep learning technology. So he has used SVMs and RFs, earlier technology, and features used as MFCCs, LPCCs, GCIs. I will not go for the expansion for all those things. Here what he tried to do is, he tried to classify whether child is male or female. In case of grown-up people, classifying male and female is easy because there will be some modulation in the voice. Female voice, male voice, there will be change. What makes this change? What modulation? Frequency, very good. Which frequency? Frequency of what? Frequency of speech. One more step further. So normally while we speak, there are some organs here at the throat which we call as vocal folds. Those vocal folds vibrate, continuously vibrate. How many times they can vibrate per second is a frequency. Males will have different frequency, females will have different frequency. Whose frequency is more? Female? Why? There are more males, no, more frequency should be, male frequency should be more. But it is not voting, unfortunately it's not voting. Female frequency is more. If frequency is more, then voice will be more melodious. At least that we can say, female voice is more melodious, isn't it? But children voice, still more melodious. Children voice, small child, 1 year, 2 years, 3 years. So children voice frequency is more than even female frequency. In case of males, it is around 120 to 150 hertz. In case of females, it is 150, 160 to 240, 230. In case of children, it is up to 300 hertz. Classifying children as male and female is very difficult task because there is no change in the frequency. But in case of males and females, grown-up males and females, it's very clear. So this boy did that work of classifying children using these classifiers, and those features got better results. What my intention to show this slide is which classifiers we had used to be intact in research. Earlier, this is a work done in 2015-16 during that time. So, gender identification again he used more number of features. More number of features means more data. So, once more data we have better classifiers. Now, artificial neural networks, deep neural networks, all these things are used. So, again classification, this classification results are better, means for speech processing we are using now different classifiers. The second student who has worked on scene classification. Scene classification in the sense, if you keep a microphone here, it should sense what is happening. So, those happenings are some events. Seeing those events, your device should decide where you are, in which scene you are. Say for example, I am moving into a meeting room. It should, my mobile phone should identify meeting room and automatically it should turn into silent mode. Otherwise, sometimes it creates some problem, isn't it? Very serious meeting is going on and it suddenly starts ringing. So, if we are in a kitchen, then there are some cutlery sounds, then some water tap running sound. If you are in a hall, then TV sound, some different sounds. So, these are called as events. Seeing these events, will you be able to decide scenes, which scene it is? Fine. So, that is the work this boy has done. So, again he has defended his thesis in 2020. He has used little advanced, this is just explanation of what he has done. So, you have some events, but those events are not overlapped. They are seeing one car, somebody speaking, then footsteps, again car. These are not overlapped, but here car sound is also there. Along with that, someone is speaking, again car sound, someone is running. Overlapped speech events we call them, separating them and identifying them, then deciding what is the scene. So, don't worry about all these things. So, he has used here he has used SVM. Again the features are bag of audio words, Fisher vectors, fusion Fisher vectors, all these things. Let us not worry about that. So, the percentage of recognition was 44%. It is a good percentage at that time. Now, people have reached 60-65%. Means we had started using, you see so many things, as CRNN he has used, then CBRNN he has used, then CNN he has used, DNN he has used. DNN is an advanced version of CRNN and all these things, deep neural network. So, this is next student's work. She also works on a similar things, but she has worked on some rare acoustic sounds. Rare acoustic sound in the sense, night 12 o'clock you hear some girl screaming or some accident sound. Normally, your CCTV camera or something is not able to capture it. At that time, if you put microphones can capture, even if some line of sight is not there, then microphones can capture that. Then police can be alerted, then some medical assistance can be given if some accident or something. That kind of work this girl did. She also, you see, there are many things here, don't worry about all these things. So, again the same thing. She also has worked on localization of the sound. Localization of the sound means from which end the sound is coming. Here is a microphone. If we can decide that that sound is coming from this side, then we can send the assistance team to that side. That kind of work she has done. So, these are the recognition performances, and she has proposed her own network, FusionNet. These are the features she has used and these are the networks she has used. Means slowly as days come, we are improving our classifier capabilities. So, that is what sustainability can be kept in research. Don't worry about these things. Okay. So, we have come to conclusion because people are waiting for me to complete. So, fine. Speech is an important biometric information, biometric signature. We can process the speech and decide so many things, like speaker we can decide, gender we can decide, who is speaking, that we can decide, which language is being spoken, in what emotion a person is, and even interestingly we can decide age of a person roughly to some 1 year or 2 year tolerance, which has got lot of applications. Like if a person is riding a bike and he says that I am 18 years, we get license, or 21 years, 18 years, then he says that he is 18 but he looks like 14 or 15, then a police person can ask him to tell his name in a microphone, and you have one app, backend app, which will tell he is not 18, he is around 14, 15. Then further investigation can be done and can be continued. In a voting booth, a person goes with a voter ID card of his brother and wants to cast a vote, and if polling officer comes to know that or suspects that his age is not 18, then he can stop him just by hearing his voice. So all these applications, forensic applications we have. So such many applications are there. So if teachers and students are interested, you can continue research in that. Then through organizers of this conference, you can also contact me if you want to contact and want to work on this. So we can do a lot of good works on this. So some important references. Okay. Any questions? Any comments? No questions? Can ask at least some general questions from where are you, isn't it?
So now this is open question forum. So you can ask doubts, some queries or questions if you would like to ask from the professor. Because this is a very innovative field. You can take this field as a research, means how to work in the speech recognition, how to apply the machine learning algorithms. So right now this is an open forum. If you have any questions, so please ask. Definitely, I'm hoping some student will ask some questions. So you are from the academics. So if you have some doubts, so please ask. Students. No question. I think the lecture is very clear. No doubts.
Other possibilities also there.
No, other possibility is not there, sir. It was a very interesting session. So thank you once again, sir, for sharing your valuable insights in the field of artificial intelligence and machine learning through very, in a very interesting manner. Sir has shared multiple stories how AI and machine learning works in daily life. And sir has started his speech from AI and machine learning and just went through the journey of how to come to the speech recognition. So right now the speech recognition has multiple applications. The professor and the students can take this field as a research and can work in the field of speech recognition. Now I would like to request Dr. Manish Sharma sir to kindly felicitate Dr. Koolagudi sir with a token of gratitude. Thank you, Koolagudi sir, once again for accepting our invitation and to deliver a very fantastic and very informative speech on speech recognition and how can we apply the machine learning in order to process the speech. Thank you very much, sir, once again.
Thank you, sir. Good morning, everyone. It's an honor to have with us today Dr. Gaurav Mittal, a scientist at DRDO, who has graciously accepted to be an observer for today's sessions. May I request Dr. Amit Kumar to kindly felicitate Dr. Mittal. Sir, if you could please join us on the stage. Let's welcome him with a huge round of applause, everybody. Let the applause continue. Thank you. May I request Dr. Manoj Divakar sir to also join us on the stage? Thank you, sir. Thank you, Dr. Mittal, for taking out time from your busy schedule and being here with us today. Thank you once again. We'll now quickly gather for a group photograph, followed by a 30 minutes tea break. So may I request all 10 minutes tea break, all right. So may I request all the faculty members to kindly assemble here for a quick group. Okay. All dignitaries, faculty members, students can also.
students, please fill all the front rows. Start from the second one.
सर माइक और कैमरा की परमिशन सर जी
Krishna sir, can you hear me?
Yes. I can
Thank
hear
you. Thank you very much, sir, for your quick response. Okay, so welcome back. The next keynote speaker is Dr. Krishna Kumar. He has published many research articles in reputed journals. He has also authored, edited 13 books with publishers such as Elsevier, Wiley, Taylor and Francis, Springer, and River Press. His current research interests include AI/ML, cloud computing, IoT, conditional monitoring, and energy informatics. Dr. Kumar is joining us virtually to address on the title Revolutionizing Energy System with AI, IoT, and Cloud Computing. Welcome, Dr. Krishna sir. Over to you, sir.
Thank you. Thank you. First of all, good afternoon to everyone. It is truly an honor to address you as a keynote speaker at the 4th International Conference on Innovative and Sustainable Computational Technology. I extend my heartfelt gratitude to the organizing committee for inviting this conference as an inspiring platform, and I hope it energizes and enlightens each one of us to advance research and professional endeavors. Today, I'm excited to delve into the topic revolutionizing energy systems with AI, IoT, and cloud computing. Before we begin, let me briefly introduce myself. Amit sir has already told me about myself. So I'm Krishna Kumar, working as a postdoc doctor and project lead in the Research Data Infrastructure Project at Division of Water Resources and Engineering and Center of Middle Eastern Studies at Lund University, Sweden. So the main focus, my topic is basically energy and how we can use the advanced technologies to maintain the operational issues as well as the technological challenges using the advanced IoT, cloud computing, and AI and machine learning algorithms. So energy is basically the capacity to do the work, and if you are going to classify the types of energy, so it can be classified as kinetic energy, potential energy, thermal energy, chemical energy, electrical energy, and nuclear energy, and many more. You can sub-classify under this types of energy, but these are the main classification of the energy. Yes, so energy can be classified, as resources basically, non-renewable and renewable. So, you know, the non-renewable is basically not replenished. After, let's say, in a human life, it cannot be replenished. So, the fossil fuels like coal, oil and gas and nuclear is considered to be fossil fuels, and they are non-renewables. And if you're talking about the renewable, they are naturally replenished after use. So these can be classified as solar, wind, biomass, hydro, tidal, and geothermal. So in case of renewable energy sources, we can classify in various sections like ocean, geothermal, solar, hydro energy, wind, and bioenergy. I'm not going to in detail of these energy sources, but yeah, these are the classifications. And if we are talking about the global energy consumption trend, so you can see most of the energy, one second, where is my pointer option? There's a pointer C. So the most of the energy is coming through the oil and coal, and these are basically the fossil fuels, which is basically emitting gases, harmful gases to the environment, which is the main source of global warming. So you can see that around 25% through the coal, energy generation is through the coal is 25%, and 30% from the through the oil, and 22% from the gases. So it means the major portion is coming through the gas, oil, and coal. And if you are talking about the fossil fuels, it is around 55%. So this fossil fuels, non-renewable energy sources will play a major role in the greenhouse gas emissions. So the solution is basically the renewable energy. So we need to sit on the renewable energy. Here we can have the glimpse of over 40% of the energy-related carbon dioxide emissions are due to the burning of fossil fuels for electricity generation. And if you want to see the worldwide scenario, so China is basically responsible for 29.18% of CO2 emissions. And you can see that India is at place third, and India is emitting around 7.09% of the CO2. And if you are comparing with all this and with the Sweden is emitting 0.13% of the CO2. Actually, in Sweden, most of the energy generation is through the wind power. They have some hydro also, but very limited, and they small hydropower, not big dams at all. So the challenging task is basically the integrating, and if you are going to classify, if you are going to integrate various types of renewable energy, so it will impact the stability of the grid. So we need to maintain the grid. So if you're talking about the residential and commercial distribution, you can have one wire from the distribution line, maybe the single phase or three phase wire to your home, and it can be monitored through one single meter. But if you're talking about the community level distribution, which is around, the energy consumption is around 500 kilowatts to 5 megawatts, so we need the distribution line. And if you are talking about the centralized utility scale grid generation, which is more than 20 megawatts, so you need the big transmission lines to transfer power from one source of energy to the load, basically. So the challenging task to stabilize the grid is basically frequency stabilization, voltage control, and load control. So we need to take care about frequency, voltage, and load to keep them balanced. You can have we can see the supply side demand. So generation, not demand. The demand side is here. So during the morning to evening time, we will have maximum energy generation through the solar, wind, and hydro. So this one can be considered as a cumulative generation. And if you are checking the demand side, you will have the higher energy demand in the morning and more energy demand in the evening. But you will have the less energy demand between morning to evening. So we need to provide the energy when the demand is high, and we need to store the energy when demand is less. So the excess energy generation can be stored in some media, it can be if you're talking about hydropower, we can make one big dam and we can store the water potential, and we can release that water to generate energy whenever it's required. Or alternatively, we can have also battery energy storage and all. But to store the huge potential, we need the big size of battery, not big size, I can say big stacking of the battery. So it is not feasible. Then we should have integrated approach some battery storage, some hydropower storage like this, and we can have the feasibility to stabilize to resolve this peaking issue, generation and demand mismatch. matching. So basically the smart grid, if you are considering, so one main idea is basically in a smart grid, we will have the two-way communication. We will have the information about the energy demand, and we will have the information about the energy generation. And we need to have the various, and we will also have the various storage capacity like battery and dam. So we need to have the models to regulate this kind of information, to speculate the parameters which is required to stabilize the grid. So in case of a smart grid user, basically smart grid uses digital technology to manage electricity flow and issues more intelligently, unlike spoke and wind power grid, where power flows from a central power plant to your business. Smart grids allow you for more dynamic energy sources. So if you are comparing with the smart grid is for the big area, like if you are talking about the northern grid, southern grid, eastern grid, central grid like this. If you are talking about the microgrids, it can be classified as a grid which is basically local. Let's say, let's consider one hilly station, maybe for the Uttarkasi, maybe for the Josimat, and maybe for another areas which can be have the integrated approach of microgrids. So it's basically in microgrids we will have one kind of bus, either AC or DC, but DC buses generally uses for the long distance transmission lines. So this will consider as a smart grid for the big transmission lines. But for the AC line, you can have directly generation, but it also depends on the type of energy generation. Like if you are generating energy, so this through the solar, so this energy will be in DC, so you don't need to convert it into the AC. You can directly use it use as a load. So you can directly connect the load and you can utilize the energy. Similarly for the fuel cell, similarly for the energy storage. But if you have the hydropower, then you can directly utilize as the AC energy. Similarly for the wind. So it's depending on the type of energy generation and the type of load. So if the type of load is AC, then you can directly connect through the AC. If the type of load is DC, then you need to have the conversion analog to AC to DC converter, and then you can utilize that energy. So the main benefit and challenge of the smart grids is benefit is basically better utilization of existing capacity of electrical assets and increasing the penetration of renewable generation, because if you have the many integration of many type of energy sources, then there will be an issue of grid instability. Then this, the smart grid concept can maintain this grid instability. So increasing the reliability, resiliency and flexibility of the power system. Also, you will have the option to check the vulnerability of the cybersecurity issue, which can be, using the smart grid techniques, we will have the option to maintain the cybersecurity concern. As also, like if you are going to integrate various renewable energy sources, then obviously the greenhouse gas emission is going to reduce. And this one is also creating jobs. So very interesting one, like smart grid is not only the area of electrical engineering or mechanical engineering. Now the smart grid is giving the concept to have the integration of electrical, mechanical, civil, every kind of, even the hydrology also. So you will have the integration of many types of jobs. So you will have many opportunity as well. Fine. So if you are talking about the limitations, so the main limitation is basically the infrastructure. So you need to develop the infrastructure, and this involves basically cost, cybersecurity concerns, and interoperability of the devices. And if you are talking about the data, so you need to store that data, and also you need the processing power to process that data. So building a smart grid modernization strategy, there could be many strategies, but I can classify mainly three. That there need to be a careful strategy when it comes to modernize existing equipment. The first step to creating a smart grid plan is to identify the existing infrastructure, current area of vulnerability, and goals for modernizing plan. This plan can involve researching and adding new technology like IoT and automation that will result in a more efficient and adaptable electric grid. So for the future, I mean the smart grid, if you're going to integrate, so you will have the energy management systems, advanced metering infrastructure, IoT projects, because you need the sensor. So IoT could be the one of the sensor, and demand response management, and the electrical vehicle and the big data. Electrical vehicle, I will explain a little bit more about this because it's also a very challenging task to in which this electrical vehicles can help to stabilize the grid. So I'm starting with the smart meters. So you will have the features to improve the network planning, improve customer service, improve the quality of supplies, and reduce time of the power plants and transmission lines, increase energy efficiency, and you can propose some new tariffs, smart products consumption control, and self-production if you are generating from the solar, and if you are generating excess amount of energy, then you can have the self-production, and you will have also the electrical vehicle. So previously we used this conventional meter, but now we are using the smart meters which have the facility to store the data and management, end-to-end communication, bi-directional metering and billing, because you can also produce energy through the various energy sources and mostly solar. Then if you are generating excess amount of energy, then you can get the tariff from that. So there should be requirement of bi-directional metering. So you can transfer energy from your production house to grid, or you can take energy from the grid for your house or load. So it could be a bidirectional one and interactive display, because previously it was the analog type of meters. Now you have the interactive display which can also consume less power compared to the analog meters. Detection and diagnostic of the system faults can be also possible. Physical and wireless connection is also possible. Like you can have the wireless connection for your smart meter, or you can have the physical connection as well. So if you're talking about the layers of smart grid, so it can be classified mainly in three categories, like physical infrastructure layer. So you can have the communication between the generation, transmission, distribution, and process, field, station, operation, enterprise, and market. So these could be on the physical infrastructure layer, and the second most important one is the communication layer, where you can have the communication network for the physical devices that connect across the electric grid. Also, you will have the connection with the IoT. And the third one is the application layer, where you will have the many application softwares, which like tools for the data analysis, predictive analytics, and give grid operators more control over the energy sources. So you will have the huge data through the various sources of energy, maybe through the generating stations, maybe through the transmission line, maybe through your smart devices, and this data will be collected through your smart meters, which is basically used, which will be basically stored in a big data storage like in Amazon S3. So you will have the option to analyze this data. Data will be acquired through the various sources, and you need to prepare the data. You need to filter some data based on your requirement, and then you can have the machine learning algorithm to take the decisions. So if you're talking about the blockchain technology, so there is a huge potential of this blockchain technology in the energy informatics, because like you will have the option to in the smart grid and energy trading. So in smart grid, you can have the records like energy generation, transmission, distribution, consumer, and small scale generation, energy metering, cyber attacks, cyber security requirements, security standard and protocols. And if you are talking about the trading, so you will have the generation side information, consumer side information, and V2G, vehicle to grid information. So this data can be secured through the blockchain technology, so that nobody can tamper your data, and you will have the accurate information about the data. So I was talking about the electrical vehicles. Nowadays, the electrical vehicles is being started being used as a vehicle to grid concept. Like whenever the energy will be accessed, then you can tap that energy to charge your vehicle, and whenever the energy requirement on the grid is high, then you can transfer your energy through your car battery to the grid. So this is basically going to stabilize your grid. So now the V2G, I mean vehicle to grid concept, is basically being focused to part of the smart grid, and it will help to stabilize the grid. So this concept is basically the, I can say, like data hunger concept, and you need to continuously connect your electrical vehicle through the communication channel, so that you can provide the continuous data generated through your vehicle to the grid, and this can be help to stabilize your grid stability. So vehicle to grid concept basically responsible on the basically charger, type of charger. So if you're talking about the type of charger, so it can be classified in 3 levels, level 1, 2, 3. And if you're talking about the impact on the grid, so level 3 type DC fast charger is basically having impact on the grid, because they are basically a public chargers. So this data cannot be analyzed, because at public charging stations anybody can connect the EVs anytime. But for the level 1 and level 2, which is basically connected to the home, so you will have the records, like whenever, I mean you can have the trend, like whenever the demand of charging from the electric vehicle is high or low. So depending on the charging, because if you are going to draw through the level 3 charger, so it is basically the fastest charger. So you need to draw, I mean, the power from the grid at very, the rate of charge is very fast. So you need to take the power from the load, very high power at a very fixed duration. So the impact of this level 3 charger will be high on the grid. So to meet the demand response, we have the many demand response technologies like advanced metering infrastructure. We need to have the automatic demand response monitoring, and then smart thermostat. Like if you are using AC or something, then you need to have the smart thermostat, distributed energy resources, energy management, IoT-enabled appliances, vehicle to grid, time of utilization, and time of use pricing. Like if you are going to say the users, like if you are going to have, if you are going to draw the energy whenever the demand is less, energy demand is less through the grid, then you will have the less price on the energy. And if you are going to draw the power whenever the demand on the grid is high, then you will charge for the high price. So this could be also managed through the time of use pricing. And you will also have the dynamic load control, energy storage system, smart lighting system, and peak saving with the AI. And also you will have the option to have the digital twins, and which can be for the predictive maintenance of the grid. So if something is coming or something will be happening in the future, then you can predict through the digital twins. And you can virtually create the environment, similar environment, and you can simulate the many scenarios for better planning, monitoring, and maintenance. And you can have, I mean, you can have the active maintenance strategies. Whenever the demand is low, you will have the option to take care, I mean, to maintain your system. So this could be also a possibility to help smart grid technology. Similarly, for the smart building, you will have the many sensors to monitor the heat, I mean the power consumption units. So you can control through the various devices, and also through the AI technology. Like whenever, like I'm giving one example. Like whenever the weather condition is not good, so you need to measure the temperature and weather condition outside your house and inside your house, and you can have some. And also you can have the access of the weather data, and you can implement some AI models to forecast your temperature, and then you can maintain your temperature inside your house. So there will be a maintenance, maintenance of energy basically. So if you are going to control the flow of energy, then you can save the energy also. I'm giving one example, like here you can see on the top, here is one Francis turbine, and this is for the basically hydropower energy generation. And like I have developed one strategy to predict, to monitor the condition or efficiency of the power plant. So I have the power factor prediction. Based on that, you can have the option to analyze. You can have the option to analyze the behavior of the power education system, the switchyard and grid. And through the discharge utilization factor, you can monitor the condition of that turbine. And through the machine efficiency, this will be the overall efficiency, including turbine and generator, and the control system as well. You can see this one is the new one, and this one is basically eroded one. You can see the blades, the condition of the blades. So this one is the basically erosion and cavitation inside the turbine. So this one is the bottom part of this runner. Basically, this one is not exactly turbine. It's a part of turbine and the heart of the turbine, I can say. So this one is the runner basically, and you can see the condition. All the blades are basically eroded almost. So for generating same amount of power, it will take more discharge. So based on the discharge utilization factor, we can speculate the condition of the turbine. So you can monitor the complete power station efficiency through these three parameters.
Yes, ma'am.
And you can also have the IoT kind of sensors to acquire the data from the power plants. And based on your requirement, we have basically 3-layer architecture of IoT, 4-layer and 5-layer. So depending on the penetration of your control mechanism, you will have to choose your layers of architecture. So if you're talking about the cloud computing, you will have the option to configure many things in the smart grid, like communicating. If you're talking about a software as a service, the software as a service is a third-party platform, and everything is responsible by the third party, not from the owner. So you will have the access of you will have to configure communication, ERP, CRM, games, and email if you want. And then the platform as a service, like AWS and something. So as a platform, you will be responsible for the data and application. But if you are using the infrastructure as a service like AWS, I can say, so they can provide the servers and storage and the network capacity, and they are basically responsible for only the cloud only. So you will have the access of this. You need to decide which type of service you want to take. So it could be the part of cloud computing, and you will have the option to manage this thing. So here is the model which I generated, I discussed previously. Let me show you again that slide. This one. So this one is the model, and I've integrated this model here. So this model is not in the ESP module. This model in the cloud. So I have collected various data. So if you are talking about the smart meters, you can collect the power, current, voltage, and power factor, and temperature sensors. Basically, the turbine temperatures. Like if you are having the bearings, so you need to measure the temperature. Otherwise, you will the bearings pads will be damaged, and then you will have the huge vibration. So you need to have them also monitor the vibration and the level sensor at the dam and discharge sensor, how much water is coming through the penstock to run the turbine. So this data is collected and passed through the ESP8266 module to the cloud. And here in the cloud, I have one that algorithm which basically forecast the efficiency of the machine, and you can have the option to monitor directly because it is connected through the cloud. So if you're talking about the architecture of that, so locally the machine data can be accessed by the operator, and they can have the maintenance based on the requirement, based on the real-time condition. But you can store your the historical data through the IoT sensors in your workstation, and you will have to deploy your models, and then you can have the many reports, and based on the reports you can perform the actions like whether you need to go for the maintenance or not. So here is one example like predicted efficiency of the plant. So you can see that the real-time scenario of the plant is this one, I mean the brown color, and if you're talking about the predicted, this one is the predicted efficiency of the plant. So you can maintain, you can have this kind of machine learning models to check the efficiency of the power education system, to check the efficiency of the machine, to check the efficiency of the overall plant. So based on that strategy, you can develop your own maintenance strategy, and you can reduce the downtime as well. So yes, so this one is the city of Lund at Sweden, and this one is very close to the country Denmark and the city of Copenhagen. And here is my department. This one is the admin building, and this one is my center. And recently we have started one United Nations Water Hub at Lund University. And here is basically a Professor Marwala. He is the rector of the United Nations University and Under Secretary General of United Nations. And he is basically Professor Dr. Kamil Madani, Director of United Nations Water Hub. So we have recently started United Nations Hub here in the Lund University, and we are working on various problems of the water. And we are also working on the energy, how we can utilize water to extract the energy efficiently without harming the environment. These are some pictures when I was working with the Rolls-Royce. So basically Rolls-Royce was basically, actually most of the people is knowing Rolls-Royce is a car making company, but no. Rolls-Royce is a car making company, but that I was with the Rolls-Royce jet engine division. So there is two companies. The original company is not now the owner of the original company is not basically Rolls-Royce, but the owner of this jet engine is still a Rolls-Royce. So I was talking about hydropower plant because I work with the 𝐂𝐨𝐬𝐿 Limited, you know, Uttarakhand Jal Vidyut Nigam Limited for more than 10 years as a sub-divisional officer. And I work at Uttarkasi and Vikas Nagar, and also in the design unit of Dehradun Design Center. So this one is the Tilot Vidyut Greh, I mean the Tilot power station at Uttarkasi. It's a 90 megawatt power plant having the Francis turbine. This one is a dam in the Dark Pathar. It's a Biasi hydro power project. This one is the power evacuation system. I mean switchyard. This one is the generator floor basically. So upper part is the generator, and you will have the lower part, which is basically a turbine. Here is the generating transformer. So this could be I think 100 or 90 MVA transformer. So very big one. This one is a 4.5 megawatt solar power plant, and basically it is installed at the Dark Pathar barrage. And thank you for your attention. And yeah, if you have any query, you can write me and you can ask me.
Thank you, Krishna sir. Thank you very much. So,
Thank you, Mr.
I think this is a open forum to ask any questions. If the participants would like to ask any questions, so please ask. Any question from the side of participant? So there is no question. I think everything is clear. So thank you, Dr. Krishna Kumar sir, once again for sharing your valuable insights on implementing artificial intelligence in building efficient energy systems and integrating cloud computing. You touched multiple topics, means how can we use Internet of Things in energy, how to store in a big data, or how to work on the cloud. So thank you, sir, once again for sharing this valuable informations among us. And once more time, I would like to thank you to accept our invitation as a keynote speaker. Thank you very much, sir.
Thank you, Amit sir, and have a lovely day.
So please
Good day ahead. See you again. Bye bye.
have a great day, sir. Bye bye.
You too.
We'll see you. Bye. So now the time to invite the students. Now we have the next activity. The student will have an interactive session on AI in IoT. So now I would like to ask student to be on the stage to conduct an interactive sessions on AI and IoT.
Do we have the group here in the room?
The student who are supposed to start the activities on artificial intelligence and IoT. Where is the student group? We are waiting for you. I am asking to the student, please come on the stage and start your activity.
On हो गया?
Okay. Hello. Should I? Very hearty good afternoon to everyone present here. I am Amritanshu Purohit, a student of first year BTech at Graphic Era. Water is the foundation of life, as you all know. essential for every ecosystem and human endeavor. Yet, this precious resource is under immense pressure due to climate change, as we all know, population growth, and unsustainable practices. And unsustainable practices. Sustainable water management is no longer a choice but an imperative measure to ensure that future generations can thrive. Today, I will explore how cutting-edge technologies, especially artificial intelligence and IoT, are transforming water resources and management. AI in water management. AI has emerged as a game changer in managing water resources efficiently. It enables us to predict water needs by analyzing data and weather patterns, population trends, and agriculture demands. This proactive approach helps us in allocating resources where they are most needed. AI also plays a critical role in detecting leaks in water distribution systems, problems that often go unnoticed but result in significant water loss. Moreover, AI-driven algorithms can optimize water distribution networks, ensuring equitable supply while minimizing waste. The Internet of Things, or IoT, adds another dimension by enabling real-time monitoring and management of water resources. Smart sensors can continuously track water quality, detecting contaminants early to prevent health risks. In agriculture, IoT-based smart irrigation system monitors soil moisture and weather conditions, delivering water precisely and when and where it is needed. This reduces water waste, boosts crop yield, and supports sustainable farming practices, especially in drought-prone areas. Real-world examples highlighting the power of these technologies are IoT-enabled water meters in urban areas, as well as water water consumption and promoting conservation in drought-stricken region of India. Smart irrigation system powered by IoT have helped farmers reduce water usage up to 50% while maintaining crop productivity. Such initiatives demonstrate the potential of integrating AI and IoT to address global water challenges. Finally, as we navigate an era of increasing water scarcity, AI IoT stands as a beacon of hope. These technologies empower us to manage water resources sustainably, ensuring their availability for all forms of life. However, this responsibility does not rest solely on technology. It requires collective actions from governments, industries, and individuals to adopt and scale these solutions. Together, we can secure a future where every drop of water is used wisely and responsibly. Thank you and have a wonderful day.
Good afternoon, everyone. I am Satvik Malviya of BCA, first year in Graphic at deemed to be University. Currently, I am pursuing cybersecurity. So my topic for today is energy management with smart grids. So let's start with it. As we delve into these topics, we aim to explore innovative solutions that not only address pressing global challenges, but also pave for a way to sustainable future. Together, let's embark on this journey of discovery and innovation. So if we start about the role of sustainable energy management, the energy management refers to the strategic use of energy in maximize efficiency and to reduce consumption without compromising the productivity. It involves planning, monitoring, controlling energy production and consumption. Sustainable energy management is crucial in addressing global challenges such as climate change, resource depletion, and economic stability. By optimizing energy use, we can reduce greenhouse emissions, conserve natural resources, and promote economic resilience. This strategic approach not only benefits the environment, but also support the economic stability, reducing the energy costs and the mitigation of impact and energy price volatility. If we talk about how AI plays a role in its energy management, it's somewhere around like we can say that artificial intelligence plays a pivotal role in optimizing energy uses. AI algorithms analyze vast amounts of data from various sources and predict energy demand, identify and inefficiencies, and suggest the corrective actions, what we can do for the corrective measures to save the energy from our management systems. This helps in minimizing the energy wastage and ensuring the energy is used efficiently. For instance, machine learning models can be forecast peak energy demands based on historical data and current use patterns. AI can also optimize the operations of energy intensive equipment, schedule maintenance to prevent breakdowns, and enable predictive analytics to foresee the future energy needs. This dynamic and adaptive approach ensures that energy resources are used in the most efficient and effective way in the manner possible. Now, if I talk about the smart grids in the IoT, smart grids are like, you can say, advanced electrical grids used in digital technology to monitor and manage the transport electricity from all the generations, sources to meet the varying electricity demands of end users, IoT devices such as like smart meters, sensors, and automated sensors plays a crucial role in creating these responsive, efficient energy grids. Smart meters provides real-time data on energy uses, enabling consumer and adjust their consumption patterns and save energy. Sensors and automated systems can help in detecting addressing issues like power outage or equipment failure promptly. So it's like a safe way to use smart grids in IoT using that. If we now talk about a case study, it's like quite interesting. Let me share one of them. In a real world example of AI and IoT in action, in United Kingdom, UK, smart meters are being rolled out to households, provided detailed insights into energy consumptions. This data helps households make informed decisions about their energy use, reducing both consumption and cost. This introduction of smart users meters has also enabled energy companies to better manage their supply and demand, and the owners of the house who are using this know the better like how much electricity they are using. It also helps in reducing the need for fossil fuel based power plants during peak times, as we know that UK is suffering from loss and all. Another example is automated energy distribution in California, which uses AI to balance energy supply and demand efficiently. Now, if we talk about the conclusion of overall the things, the integration of AI and IoT in energy management and smart grid prevents a promising pathway to achieve sustainable development in both computational and the smart grids using AI and IoT. As technology continues to evolve, we can expect even more innovation solutions that will help us manage our energy resources more efficiently and sustainably. By embracing a lot of AI technologies and IoT, we can create a more resilient, sustainable energy system that benefits both environment and the economy. Thank you for your time and attention. Have a good day, everyone.
Good morning, everyone. I'm Pallavi from BCA, currently pursuing artificial intelligence and data science. I'm here to discuss with you an essential pillar of sustainable development, that is agriculture, and how the fusion of AI and IoT is revolutionizing through smart agriculture and personalization things. Now let's talk about the importance of sustainable agriculture. Agriculture is the backbone of human civilization, uh, feeding billions of and supporting livelihoods globally. Yet, traditional farming practices face immense challenges, from climate change to to resource scarcity and grow population. To ensure food security without duplicating natural resources, sustainable agriculture has become a necessity. This is where AIoT steps as a game changer. Artificial intelligence has brought unparalleled precision and efficiency to farming with AI powered tools such as crop monitoring and disease detections. By leveraging AI, farmers can make informed decisions that enhance productivity while minimizing environmental impact. And IoT devices take farming a step further by connecting physical tools to the digital world. Sensors, drones, and automated systems are revolutionizing precision farming in the following ways. Soil and weather sensors monitor soil moistures, pH levels, and temperature in real time. Drones and imaging technology equipped with cameras and sensors, drones maps field, analyze plant health, and even distribute seeds. These technology not only save time and resources, but also reduce the ecological footprint of the farming practices. Now we have some case studies which are on real time. First, we have social health monitoring. In India, IoT devices are being used to monitor soil health and provide customized recommendations for fertilization. This initiate has reduced the overuse of fertilizers and improved the fertility over time. Second, we have climate smart agriculture. In Kenya, AIoT powered systems are helping farmers adapt to unpredictable weather patterns by providing real-time weather forecast and recommendation for planting and harvesting. As we look for the future, the combination of AI and IoT holds immense promise for transforming agriculture sustainability. By enabling precision farming, AIoT reduces resource wastage, increasing productivity, and protects the environment. It empowers farmers to feed a growing global population without compromising the need of our future generation. In the hands of farmers, these intelligent technologies are more than tools, or in other words, they are a lifeline for the sustainable development. Together, let us embrace AIoT to create a smarter, greener, and a more resilient agriculture sector. Thank you.
The true power of AI and IoT lies in the ability to turn global challenges into opportunities for sustainable growth. Good afternoon, everyone. I am Jagriti Sharma from BTech second year, here to speak on climate changes, mitigation, and environmental monitoring using AI and IoT. Today, we face two major challenges, that are climate change and the need of innovation. Climate change is the impact of our world in many ways, and we urgently need better tools to monitor and address its effects. That's where artificial intelligence and Internet of Things come in potential solution. Let's talk about the impacts of climate changes. Climate changes is no longer a future problem. It is happening right now. Rising temperatures, stronger storms, melting glaciers, and damaged ecosystem are just some of the ways it's affecting us. To fighting this crisis, we need to monitor these changes and take action. AI and IoT are technologies that can help us do it more efficiently. AI for climate predictions. AI has changed how we predict the understanding and the climate. It can process large amount of data to forecast weather, track hurricanes, and predict natural disasters like floods and wildfires. These predictions save lives by helping the government and communities prepare. For example, AI can spot early signs of droughts, giving farmers time to act and project their crops. AI also helps us understand the long-term changes in the climate so we can plan better strategies to deal with them. Next, we will discuss about IoT for environmental monitoring. IoT is just as important when it comes to monitor the environment. IoT devices with these sensors are used in forests, oceans, cities, and other areas to collect the data on air quality, water pollution, deforestation, and wildlife. For example, IoT sensors in cities track air quality in real time, helping authorities to take steps reducing the pollution. In forest, IoT devices can detect illegal logging and monitor the health of ecosystem. This kind of data is crucial for protecting nature and preserving the balance in the environment. Next, we have the role of AIoT in tackling the climate changes. The combination of AI and IoT is a powerful tool for fighting climate changes and building a sustainable future. These technologies help us understanding the problems we face and give us the tools to solve them. However, we must use them responsibly, ensuring the data is handled ethically and everyone has the access to these solutions. In closing, tackling climate changes requires everyone to work together. By using the power of AIoT, we can monitor our environment, reduce the effects of climate changes, and build a better future. The time is to act now, and it's up to all of us to make a difference. Thank you.
A very good afternoon, everyone. Myself, Samriddhi Asthana, and it's a pleasure to be present here today to discuss one of the most exciting and impactful concepts shaping our cities and societies, that is, smart cities and their roles in sustainable urban development. A smart city is an urban area that leverages technology and data to improve the quality of life for its residents, enhance operational efficiency, and drive sustainable development. It uses a combination of artificial intelligence, AI, and IoT, that is, Internet of Things, and other digital technologies to optimize city operations and services, making them more responsive and resource efficient. One of the key drivers behind the success of smart cities is AI, that is transforming urban planning by helping cities become more efficient and sustainable. AI helps in managing resources like water, electricity, and gas more effectively. For example, smart grids powered by AI can optimize energy distribution, reducing waste and ensuring that energy is used efficiently. Predictive algorithms can anticipate periods of high demand, allowing cities to adjust supply accordingly and avoid overconsumption. Now let's talk about traffic control. In terms of traffic management, AI system plays a crucial role in reducing congestion and improving the flow of vehicles. This not only reduces the travel time but also lowers fuel consumption and emissions, making the cities more sustainable. AI is also integral to the population control, predicting population levels. Another pillar of smart cities is the Internet of Things, IoT. It refers to a network of interconnected devices that collect and exchange data, enabling real-time insights and automations. Thus, IoT is transforming urban infrastructure, making it more efficient and sustainable. A prime example of IoT's role in infrastructure is smart lighting. IoT sensors in street lights can detect movement, adjusting brightness based on pedestrian or vehicle activity. This not only saves energy but also reduces light pollution and operational costs. In areas like water management, IoT sensors can monitor water usage, leakages, and quality in real time, ensuring that water is used efficiently and wastage is minimized. Let's now look at some real-world examples of smart city initiatives that have made significant strides in sustainability. First is Barcelona in Spain. Barcelona is often considered a global leader in the development of smart city technologies. The city has integrated a wide range of IoT systems to improve urban life. Smart street lights reduce energy consumption, and cities' waste management system uses IoT sensors to monitor waste levels and optimize the collection schedules. Second is Singapore. Singapore is another example of a smart city that has implemented a range of smart technologies, including AI-powered traffic management systems and smart water management system. In conclusion, smart cities offer a promising path towards a more sustainable, efficient, and livable urban environments. With continued advancement of AI and IoT, our cities have the potential to become more connected, intelligent, and environment-friendly, transforming urban lives into a model for the future. That's it for today. Thank you and have a nice day.
Kindly be seated here. We will be proceeding for the lunch in half an hour.
delegates are requested to please take your respective seats, including conveners also.
Hello, check. Welcome back, everybody, from the lunch. We once again have the privilege to have with us Professor Dr. Girish Gupta, who is Professor of Neonatology and Pediatrics and Medical Superintendent at GIMS. We would like to take this opportunity to honor Sir and felicitate him. May I please request conveners of our conference, Dr. Neelam Singh and Dr. Parul Madan, to kindly join us on the stage, along with Professor Dr. Girish Gupta. Let us welcome all of them with a huge round of applause. Thank you. Ladies and gentlemen, let's hear it for Professor Dr. Girish Gupta. Thank you, sir. Thank you so much. Thank you, sir. Thank you, sir. Ladies and gentlemen, we are waiting for the technical sessions to get over. Once we have all the crowd from there join us, we will be starting with the valedictory sessions. Thank you.
स्वामीनाथ परिपालय शुमां स्वामीनाथ परिपालय शुमां स्वामीनाथ परिपालय शुमां स्वप्रकाश वल्लेश गुरुगुहा स्वप्रकाश वल्लेश गुरुगुहा देव सनेश स्वप्रकाश वल्लेश गुरुगुहा देव सनेश स्वामीनाथ परिपालय शुमां स्वामीनाथ परिपालय शुमां खींची तुझसे किस्मत की लकीर, हाथों में दिखता था वो प्यार, नींद न
Happy belated Mahashivratri to everyone. This one's for Shiva.
शिव कैलाशों के बसी धौलीदारों के राजा, शंकर संकट हरणा। शिव कैलाशों के बसी धौलीदारों के राजा, शंकर संकट हरणा। तेरे कैलाशों का अंत न पाया, तेरे कैलाशों का अंत न पाया, अंत बेअंत तेरी माया। ओ भोले बाबा अंत बेअंत तेरी माया। शिव जी नु सजदा चोला ते डोरा, शिव जी नु सजदा चोला ते डोरा, गौरा नु सजदा तुशाला। ओ भोले बाबा गौरा नु सजदा दुशाला। शिव कैलाशों के वासी, धौलीधारों के राजा, शंकर संकट हरणा।
What if I had started a mutual fund?
May I have your attention, everybody? Students at the back. Thank you. Thank you, everyone, for your patience. And apologies for the delays that we encountered due to certain things that were not under our control, but now it is. So as we approach the culmination of this enriching conference, it's now time welcoming them with a thunderous round of applause. We have Dr. Parul Madan joining us. Ma'am, over to you. Thank you.
Good evening, distinguished guests, esteemed speakers, respectable delegates and participants. As we draw the curtains on the 4th International Conference on Innovative Sustainable Computational Technologies, CISCT 2024, it is with immense pleasure and pride and gratitude that I address you today. Over the past 2 days, this conference has been a hub of intellectual exchange, innovative discourse, and inspiring collaborations. CISCT 2024 has brought together some of the finest minds from academia, industry, and research to address the contemporary challenges and explore the vast opportunities in sustainable computational technologies. During the course of conference, we witnessed 7 enlightened keynote sessions delivered by globally renowned experts, 105 technical sessions showcasing pioneering research and innovative solutions in the areas of AI and machine learning, IoT-enabled solutions, IEEE student branch technical debate session on sustainable development using AIoT. The range and depth of discussions as well as the quality of research presented truly underscore the relevance and importance of the conference theme, Sustainable Computational Technologies, in shaping the future of intelligent system. Now, it's time to invite Dr. Neelam Singh on the podium to officially announce the closure of this conference. Thank you.
Good evening to one and all present. CIST 2024's success is a testament to the collective efforts of many. I extend my heartfelt thanks to our sponsors and partners, IEEE UP section, SERB, CSIR, UCOST, and RCPL for their generous support and belief in our vision. The organizing committee for their meticulous planning and seamless execution. The speakers and authors for their valuable contribution, which form the heart of this conference. The reviewers and session chairs for ensuring a high standard of academic excellence and rigor. I would also like to acknowledge the unwavering support provided by the entire GIMS fraternity, our digital team who tirelessly worked to help us with all the banners, creatives, and many more things. Last and not the least, all the volunteers for their active support, and most importantly, all the participants for your active engagement and enthusiasm throughout this event. While the formal proceedings of the CISCT 2024 came to an end, I hope the ideas shared and connection forged here will continue to flourish. May the insights gained smarter, safer, and more sustainable future. On behalf of the entire CISCT 2024 team, I, Professor Dr. Neelam Singh, extend my heartfelt gratitude to each one of you for making this conference a grand success. I wish you all safe travels and continuous success in your endeavors. Thank you, and I look forward to welcoming you to future editions of CISCT. Warm regards from all the team, from both the conveners, Dr. Neelam Singh and Dr. Parul Madan. Thank you all for gracing us with your presence.
Thank you, Dr. Neelam ma'am and Dr. Parul ma'am. It's now time to felicitate all the members who have been the integral part of this conference. And to do the honors, may I request Dr. Manoj Divakar sir and Dr. Santosh Kumar sir to kindly join us on the stage. Dr. Narayan sir, requesting you also to please join us. It's now time to acknowledge all the hard work and the efforts that were put in by the conveners of this conference who have been preparing for this grand event for months. I request the dignitaries on the stage to kindly felicitate the conveners for this conference, Professor Dr. Neelam Singh and Professor Dr. Parul Madan. Please welcome them with a huge round of applause. Thank you both for all the efforts, hard work, dedication, and commitment that you have shown towards pulling off this international conference. Ladies and gentlemen, let the applause carry on. Thank you. Santosh sir and Wajid sir, if you could. Wajid sir. I would now like to call upon the organizing co-secretaries for this conference, Dr. Manoj Divakar sir, Dr. Ankit Vishnoi sir, Dr. Neeraj Kumar Pandey sir, Dr. Amit Kumar sir. Dr. Ankit Vishnoi sir. Dr. Amit Kumar sir. Thank you everybody for doing the honors. May I now request Dr. Manoj Divakar sir to please join us once again on the stage to felicitate publication chairs for this conference. I would like to call upon Dr. Varsha Mittal ma'am. Dr. Ankit Tomar sir. Thank you, Manoj sir. I now request conveners of the conference to be ready. And Dr. Ankit Bishnoi sir, if you could please join us on the stage. May I request Dr. Koolagudi to kindly join us on the stage. You have been one of the crucial elements of today's conference, sir. Thank you for enlightening us with your words and wonderful address on the usage of ML in speech recognition. That's AI. Thank you so once again. We would now like to recognize all the track chairs who have contributed immensely in this conference. Requesting Dr. Amit Kumar sir to kindly come forward. Dr. Pawan Kumar Mishra sir. Dr. Upma Jain, Dr. Neeraj Pandey sir, I stand corrected, Dr. Neeraj Kumar Pandey sir. Dr. Ashwini Kumar sir, Mrs. Vandana Rawat, ma'am, kindly join us.
भास्कर सर को बुलाना है ना अब? हाँ. So now the time to felicitate our respected session chairs who has played a very, very important role during all the paper presentation. So to felicitate all our respected session chair, we would like to call Dr. Bhaskar sir, Director Research, and Dr. Santosh S. Saraf, Dean Academics, on the stage. No, sir, no. Now I would like to call Dr. Santosh Kumar sir, Session Chair, please come on the stage. Dr. Chandrakala ma'am, Dr. Noor Mohammed, Dr. Prakash Srivastava, sir. Dr. Manish Sharma, sir. Dr. Ashwini Kumar. Dr. Anupam Singh, sir. Dr. Shipra Agrawal, ma'am. Dr. Prabdeep, sir. Dr. Hridesh Kumar. So now I would like to welcome Director Research, Dr. Bhaskar sir, and Dean Academics, Dr. Santosh Saraf sir. They came from their busy schedule, and I would like to welcome you, sir. Now the time to, sir, you will be here, sir. Now the time to recognize our paper presenter. Miss Jayashree Meena. Dr. Vishan Kumar Gupta. Mr. Mohammad Sohib. Dr. Chandra Prakash. Ms. Sipra Gupta. Mr. Jatin Verma. Mr. Ansul Negi. Ms. Sweta Bagwal. Miss Tanya Rawal, now the time to felicitate the organizing member of this conference, Dr. Prabdeep Singh, Mr. Ramesh Rawat, Dr. Hemant Singh Pokhriyal, Miss Visu Tyagi ma'am, Dr. Mansi Sharma, please have a big round of applause for everyone. Miss Supriya Avasthi, Dr. Rohan Verma, Mr. Siddhant Thapliyal, Mr. Mukesh Bhandari, Mr. Piyush Agrawal, Mr. Priyans Kumar, Miss Gunjan Mehra, Mr. Abhishek Thapa, Mr. Abhishek Thapa, Mr. Nikhil Bist, Mr. Gagandeep Singh sir, Mr. Prateek Kumar, Mr. Utsav Kumar, Mr. Saurabh Dev, Mr. Saurabh Dev. This one. Mr. Mohit Amoli. Miss Sikha Thakur. Miss Akriti. Mohammad Rehan sir. Mr. Vikas Kumar. Prabdeep is absent. Miss Ayushi Dwivedi. Mr. Yuvraj Joshi sir. कौन लेफ्ट है इसके बाद वॉलंटियर्स हैं लेफ्ट सर्टिफिकेट लाएंगे इन्हें डालो मिस्टर संजीव कुकरेती सर. Now the time to felicitate IEEE student members who has done a very hard work in the success of this event. Now I would like to call Dipanshu Gupta. I would like to invite Koolagudi sir on the stage in order to felicitate the students. ये रहा IEEE में. देख लो कोई रह तो नहीं गया.
टेक्निकल प्रोग्राम चेयर एंड कहते हैं ऑर्गेनाइजिंग कमेटी मेंबर.
क्या क्या है
इनका वो होगा टीपीसी चेयर एंड
organizing. Now I would like to call Professor Dr. Muhammad Wajid, who has contributed as a TPC and organizing chair in this conference. Please have a big round of applause for Professor Wajid. उत्कर्ष पंत, उत्कर्ष पंत, शशांक व्यास, Mr. Ankit Chaudhary, IEEE Chair, Student Chapter. Mr. Sanjay Singh, Mr. Rajat Sisodia, Adi Bhardwaj, Mr. Pranav, Mr. Anurag, Mr. Amritanshu, and Mr. Raghuvansh Pundir. Raghuvansh Pundir, now the time to felicitate the IEEE volunteer students. शौर्य भारद्वाज, जागृति शर्मा, जागृति शर्मा, पल्लवी, ये कौन की आपका हो गया? इतनी मेहनत की है, फोन की बैटरी डाउन हो गई। वॉइस निकालने से पहले भी जब आ जा रही है, ये थोड़ी आवाज़ बढ़वा दो इसकी। पल्लवी, हिमानी, Mr. Rahul Kumar, who has presented paper in the conference. Thank you, Maskar sir. Thank you, Santosh sir. Thank you, Koolagudi sir. Rahul is, yes, after this. Thank you, everyone. Now I would like to call Dr. Narayan sir, Manish Sharma sir, and Santosh sir. Santosh sir is here. Okay, so Professor Wajid sir can come and join the stage. Mr. Digvijay Singh. Kiran Kukrethi. Bhumika Sharma. Kumari Bhavna. इधर खड़ी करो, लाइन में खड़ा करो, सर्टिफिकेट लेके खड़ा करो. Shambhavi Singh. Gorangi. शिवांश गोसाई. मैम को बता दो सारी डिटेल, वो लिख भी लेंगे ना. दिव्यांशी सिंह. हर्ष कुमार. सार्थक त्यागी. सात्विक. साक्षी गोस्वामी. तनिष्क. समृद्धि अस्थाना. दीक्षांत शर्मा. अदिति नोटियाल. ध्रुव आर्या. शैलजा. Priyanshu Pundir.
So we may request you to take your seats, please. We will continue with the recognition in a while, guys. In the meanwhile, we would like to invite presenters for this two-day conference for your feedback on the stage. So it's an open feedback session. Anybody who is interested and would like to share their feedback, I request you to kindly come forward. With a show of hands, anybody? All right, thank you. We have Malika Pahava, who is here to share her feedback. Over to you.
Good evening, everyone. Myself, Malika Pahava from Commerce Department, PhD scholar. My reviews are, the conference was a good platform for exchange of idea. I came across various papers and tools used by the researchers. All the arrangements done by the organizing committee was also good. According to me, it was a good platform for having knowledge. Looking forward for many more such conferences in the state of Uttarakhand. Thank you.
Okay, so we are So one more time, I would like to call Director Research, Bhaskar sir, and Dean Academics, Santosh Saraf sir, on the stage to felicitate Dr. Narayan sir, who has contributed in this conference as a TPC chair and organizing committee. Please have a big round of applause for Narayan sir. Thank you, Bhaskar sir. Thank you, Santosh sir. Now, I would like to call Okay, we'll resume the feedback session. So if any other volunteers, presenter, TPC member, organizer, session chair would like to give the feedback about this conference, would like to express your feelings about the management, organization, and everything. So please, this is an open forum. You can provide the feedback. IEEE students also can come. Any student would like to provide the feedback. We have conducted this conference in multiple sessions. So if any one of the session chair would like to provide or would like to give some feedback about this conference, so this is a platform where you can just explain about the conference. So we have Professor Koolagudi sir from IIIT Karnataka, and he was a keynote speaker in today's conference, has given insight about how can we use the speech recognition, how can we apply the artificial intelligence and machine learning. Welcome, sir.
So this is all of a sudden assignment for me. So our seniors used to say, so if speech processing and image processing is not properly done, so what all problems happen? Because of speech processing and image processing was not properly done, entire Ramayana had happened. Because if Sita had properly recognized Maricha's voice, that it is not Rama's voice. Once he said, Ha Sita, Ha Lakshmana, and died. So she would not have sent Rama to that place. So because of that failure in speech recognition, later entire story had happened. Before that, if Sita had again identified properly that golden deer, that it is not an original deer, image processing, then again Ramayana would not have happened. So that way what sir was telling, I did not hear properly. Suddenly Narayan sir patted me and sent that you go there. So Graphicera University is not new to me. I was working here 12 years before. Whenever there is an opportunity, always I do not miss that opportunity to come here and talk to people, my friends. All faculty members are my friends. So, and feedback, as usual, it is excellent. Yesterday I was seeing the moment I boarded the flight till I reached guest house, night 3 o'clock, convener, madam herself was there in the guest house. I felt very sorry for that. I told her not to come, just send someone or give key there. And every moment she was following what had happened, where are you? And this kind of hospitality is a special feature of Graphicera. And I did not do anything. I said, she asked me whether you want to come, please come. I said, yes, I will come. Then later everything she did, booking of flight tickets and arranging for the taxi and booking room, and till night 3:30 she was in that guest house. So this is amazing. So this is a culture here. I am very happy because of that. And all students, morning 8:30, 2 students are in front of my room. They were calling me. That's all the thing which we have to learn. So whenever we are students, we have to learn all these things. Organizing, these are called as organizing skills. After you go to some company, what they will see is not only your technical knowledge. So how best you are in a group, how best you can manage the events. So all those things we learn here very well. I got an opportunity to meet all my friends, to spend some time. I'm very happy for that. Food was excellent, and audience also were very nice. While morning I was giving a session, so all of them were not asking any question. No, they decided not put me in some trouble, it seems. So, but my advice to all of you is, whenever there are a lot of doubts, if you keep those doubts within you, there is a less chance of growing. Even if a smallest of the small doubt if you have, you ask those doubts, either elders, seniors, teachers. In the class also we sit like that. Those who take chances, those who take opportunities in front of us only, they grow. Majority, we see our friends will reach different heights, isn't it? Manmohan Singh recently, our Prime Minister, who passed away yesterday, if you see his journey, academic growth and journey, so that way, majority of his classmates were telling yesterday opinion about him, that how he was different while asking, while clearing the doubts in the classes. That kind of attitude we have to grow. Otherwise, all of us would have conducted online classes, isn't it? Why we come to college? This creates a special environment for all of us to grow such kind of non-academic skills. That's important. These conferences also are conducted just, you need to interact with the people, you need to talk to people, you need to see what other people are working. So based on that, you can see where we are, and that is a platform or steps for you to grow. So thanks Graphicera team and both Neelam madam and Parul madam and their team, so for nicely organizing this conferences. So these things are just like pickles in our lunch or dinner. We have regular working of teaching, again attending classes, writing exams, evaluation, all those things. In that hectic schedule, these 1 or 2 days are just a change where we learn a lot. So these kind of things, if you arrange more in future, that's good. So thanks, madam, for calling me. Thank you.
Thank you very much, sir, for your nice words about the conference, the organizer, convener, and the complete team. Thank you once again, sir. Thank you very much. And we also enjoyed your session that was based on the speech recognition. Thank you once again. Now, any other volunteers, any other delegates, TPC member, session chair? So this is the last call. If any one of you have something in your mind, you are thinking, okay, I have something in my mind, or I would like to share about this conference, you can also praise the food, tea, high tea, and everything. If any one of you would like to come, I am expecting something from IEEE volunteers. Okay, so thank you very much. Now, I would like to call our respected Dr. Santosh Saraf, sir, Dean Academics, Graphicera deemed to be university. Sir, please pardon me, I'm not asking your permission. Please say a few words about the conference. Thank you, sir.
Sir mentioned speech processing. If information gap is there, Amit forgot to tell you one thing. As Dean Academics, I told him that if you give feedback, you'll get 5% marks extra. He forgot to tell you that. So, see, end of the day, given a chance, if you try to take that opportunity to come on stage, okay, you tend to lose. So, you lost 5% marks this time. Next time, see that you don't lose it. I was part of this conference. More important is the awareness which we have to get among students with technology. I hope all of you, even it has become to come to such an extent that even your WhatsApp chat is now getting generated by LLM. Okay, and what I would like to tell you all is try to explore what happens and how LLMs are trained and what is the power which is used to get them to this stage. Okay, so any machine which is running, it requires power, and we already had an example of a photographer running out of battery. Okay, so these conferences, as sir mentioned, are a forum where you can interact with people, try to understand ideas, and as one of the delegates who is from commerce background was here, there is one barrier or the thing which happens with computer science graduates. I'm not one, so that I can blame. Okay, so you feel that you are complete. It is not like that. Unless you open doors for interaction and collaboration, your computing will not survive. Okay, and again, being in medical college, okay, this is a rich area where computing can go further. So I want you all to think with your open mind, saying that anyone can come in and partner with you to see that we get good sustainable computing solutions. And I don't know who has designed the logo. Sir, how did you get that logo? There is a team which decided that, or was it a theme? Yeah, it can, in fact, it tests your viewpoint. The positive viewpoint which sir said, he wants to show computing is growing and there is a tree growing on it. But there is another information also. If you don't use computing, your environment also can remain safe and grow. Okay, so see, all in all, again, for me, there is one more happiness is we did one initiative where for Koolagudi sir, we recruited faculty, trained them, and they were our students. And I was happy today to hand over organizing certificates to them. I hope they will grow further and do well in this profession. And all the best for you all. And again, I've been telling this in different forums. You don't remain in compartments. Okay, your AI or machine learning will work on data sets which are not created by you. It is created by different fields. Okay, so you will be just a person who's going to program a machine to do predictive or classification, whatever. Okay, so try to collaborate and try to see that you come up with new solutions. And being in a place like Uttarakhand, at present, sustainable practice is a very difficult proposition. I can't save energy by saying that I'm not going to heat my room. Okay, I need to survive the cold. But then designing solutions to have a sustainable environment for people to survive, okay, becomes a very important initiative by all the students. Okay, and I would like to, we'll be meeting in the campus, so I'll like to see you all in other departments. Okay, CSIT should not be your boundary. Okay, all the best. Thank you.
Thank you very much, sir, for your nice words. And we are blessed we got a chance to hear something which is very, very important from your side. We have to work on the sustainable development of the computational technologies. And thank you once again, sir, for your nice words. Now I would like to request all the session chair, the dignitaries, all the respected teachers, they can proceed for their high tea. And meanwhile, we will just continue the felicitation ceremony, so you can move for the high tea. Students will be stay here. So now I would like to request convener, Parul ma'am, Neelam ma'am. Okay, so we are resuming the felicitation ceremony to the students, Sanjay Singh. Please come on the stage. Sanjay Singh is IEEE Vice Chair, Student Chapter. Rajat Sisodia. Parul ma'am also can join, please. Lakshya. Shashank Verma. Srishti Rana. Garv. Daksh Nautiyal. Krishna Chaudhary. Aditya Kumar Bhardwaj. Aditya Kumar Bhardwaj. नाम पूछो ना उसका, सर्टिफिकेट दो उसको. समर जमाल. Shlesha Best. Purab Sharma. Priyanshu Pundir. Shivansh Gosai. Please have a big round of applause for all the students. Please have a big round of applause for all the students. Very soon you will also get high tea with some pakoda also. Some biscuits, some cookies you will also get. So now the time to felicitate the students. Divyanshi Rawat. Priya Kumari. Nikita Rawat. Rashi Gupta. Divya Sachin. Sachin. Shreya. Abhinav Jain. Ansh Gujral. Ansh Gujral. Ansh Gujral is busy in taking photographs. You can hand it over to your friend and please come on the stage quickly. Jatin Gumbar. Aman Rawat. Abhijit Kumar. Gaurav Badoni, Sahil Singh, Sahil Singh, Jay Nelwal and Rishi Raj. If any student, any volunteers, any important member is left, so please you can raise your hand. Yes, please, I would like to request to the IEEE volunteers, please note down their names and ready the certificate for them also quickly. Divanshi, नहीं वो देंगे कुछ देंगे. Convener, please wait. अच्छा. Divanshi, now at the last but not the least, I would like to call Mr. Dev Verma, who is taking photographs capturing all the moments of this event since morning, and at the last his camera battery is also drained. So you can think about it, how many photographs he has taken and how many hard work he has done. Dev Verma, please have a big round of applause for him. Now I would like to thank all the students, volunteers, delegates, session chair, TPC members. They have contributed in this conference. All of them has done very hard work. I would like to thank the media staff, the IT team, the organizer, the housekeeping staff, the food staff, and all the delegates and the members who were associated directly or indirectly with this conference, CISCT 2024. So I got some information from the backend, some student volunteer certificate. The volunteer students who didn't get the certificate, they can directly contact to the convener, Dr. Neelam Singh or Parul ma'am, and you can receive their certificate from them. The student who missed or who didn't get the certificate, they can contact to convener to get the certificates. So now the time to say close of this conference event. So to close this conference event, I would like to call convener of this conference, Dr. Parul Madan ma'am. Yes, ma'am. She will officially close the conference. So I can request to the Neelam ma'am also. Neelam ma'am and the Parul ma'am officially close CISCT 2024 conference.
Good evening, everyone. I especially thank you all the student volunteers who were there for within a very short notice. I am also thankful to everyone, each and everyone who is present here, the media team, the volunteers, the organizing committee, those who had spent their nights to help us in organizing this event. I once again thank you everyone who is present or who is not and who had contributed in any way to our conference. Thank you all, and we now officially close this event. Thank you for coming.
Thank you. Now the student can also proceed